Right, good afternoon, everybody. We'll get started. As Kate said, there will be an interactive element about halfway through. I do know it's a Wednesday afternoon, and I want to try and keep it quite pacey, but also get people involved as much as possible. And I do really want to hear people's views. So please feel free to put things into the chat. Kate's going to monitor it. She's going to butt in when she feels it's appropriate, but I will also give some space throughout the presentation to give you an opportunity to put some questions in the chat. But let's get started. So, hi everybody, my name's Will, and welcome to the Maths Mastery Primary webinar. I'll start briefly just explaining who I am, if you didn't know. So I lead the Mathematics Mastery Program here at AC Plus, and that means that my role is to support the development of the program, how to make it better, and to help everybody who uses the program to meet the needs of their pupils in maths. I also work really closely with the ARC schools as their development lead, which means I go into schools every week and I support teachers and leaders to improve their maths practice. So much of what I'm going to share has been developed in collaboration with teachers and leaders at ARC and tested on the ground in real schools with real pupils. Um, so today we're focusing on foundational knowledge in maths. And firstly, we're going to start right from the start, right from the beginning. We're going to explore what foundational maths is, and crucially, why is it important? And crucially, in the context of recent curriculum and assessment review process, which I'm sure you're aware of. A kind of spoiler alert, which I don't think will be a spoiler for most of you. Foundational knowledge is mentioned a lot in that document, so it's really not outrageous to think that this will be a major focus of the new curriculum due in 2028. Especially since it's already a focus for Ofsted under the new Ofsted framework. We've recently published a guide to support schools when thinking about their curriculum to ensure that it is inclusion-led. And this really also ties into the wider curriculum and Ofsted requirements and has a big focus on foundational knowledge. Lastly, what I'm going to do is drill down into one specific area of foundational knowledge to explore what that looks like. So actually give some examples of how you can teach one specific areas of foundational knowledge. And that area is going to be multiplication and division facts. And I'm also super excited to share some new resources that we've been developing. And this is the absolute first time that I've shared these publicly. So it's a genuine world exclusive. Ta-da-ta-da. Right, let's get started. So what is foundational knowledge? So in Maths Mastery Primary, if you know our program, vocabulary and oracy are really important. We always introduce keywords, which we call star words at the start of every session. But what are the key concepts here? So when we talk about foundational knowledge, this can get confused with other similar or overlapping concepts such as core knowledge or fundamental concepts. And indeed, the curriculum assessment review isn't really that consistent in the words that it uses, which is kind of a bit unhelpful. We could get really caught up in these definitions and exactly what they mean. But I want to give you my understanding, which I believe is helpful, namely because it's deliberately really, really simple. So here it is. Put simply, foundational knowledge is the things that is the most important for pupils to know. That's it. And actually, if you're planning a curriculum or lesson, probably the most useful question you can ask yourself is this the most important thing for my pupils to know at this point in time? Types of foundational knowledge that immediately spring to mind are things like number facts and times tables, and we'll come back to that, as I said, later. Once you have this definition in mind, you may also need to be, as a teacher or leader, constantly thinking, okay, we know what foundational knowledge is. Have these things been taught in my curriculum? And actually, crucially, have these things been learnt? Because it could have been taught, but it could not have been learnt. And it's really important that we make sure that the coverage is there, but also that the deeper learning happens. And we shouldn't move on if these things aren't learnt. And we should be really careful to fill in gaps in knowledge if these gaps become evident later. And as I'll say, and I think a real theme of this webinar will be the importance of foundational knowledge and making sure as an absolute non-negotiable that your kids have foundational knowledge in maths. So who does this concern? So it may seem obvious, but it's really helpful to remember who needs to be thinking about foundational knowledge and why. So ultimately, prioritizing foundational knowledge, as we will see, is to guarantee success for every child. Because if you don't get the foundations right, you can't build later knowledge. And that, as with most things in schools, starts with leadership. So, acknowledging the importance of foundational knowledge development in the curriculum and crucially in professional development. So, leaders constantly thinking, do my teachers know what the foundational knowledge is for their year group? And are we supporting them if they don't have that knowledge? And that kind of leadership priority in turn allows teachers to actually get on and teach it, but they themselves need to know what that knowledge is and techniques and strategies for teaching that really, really well. And right now, let's be honest, things aren't exactly working perfectly, as this table, which was actually included in the Curriculum Assessment Review report, shows. And I think this is a kind of symptom of things not working as they should. And like they really aren't. A third of pupils don't achieve a level two in maths, which is the equivalent of a grade four, age 16. So if that's the sort of the situation, then the cure, according to the curriculum assessment review, is to go right back and ensure that those foundations are taught better. And I do want to dwell just for a second on these stats, because it's really important. And they're especially depressing for disadvantaged pupils. And what this shows is that over 50% of free school meals pupils don't achieve a level two, which is a very basic expectation. So essentially, if you are from a disadvantaged background in England, it is more likely than not that you will not leave secondary school with good functional skills in maths. And kind of if you think about all of the many, many hours of teaching in a child's educational career up to that point, it's really quite shocking that despite all of that, they're still not able to get that basic maths qualification. So there is plenty of work for us to do, and foundational knowledge is absolutely where it needs to start. Now, you might be thinking that, well, this is not a new, it should not be a new concept. And you might say that this is kind of obvious that we should be focusing on those foundational skills. And this is, and to be right, this is an absolutely important area for teachers. Deciding what knowledge is important or more important has always been a part of good teaching. But as I said right at the start, it's definitely a focus now, and you are hearing this phrase foundational knowledge time and time again. And it is what Ofsted will look for when they come and look around your schools. How are you supporting all of your pupils to develop those absolutely essential knowledge and skills in every subject, but especially maths and English? So this is the last sort of scene setting slide, but I wanted to show you the actual words from the curriculum assessment review that refer to foundational knowledge. And I'll just pause for 5-10 seconds just so you can read it. So as you can see, there is a clear link to the problem. There isn't enough time to teach those basic core things, that foundational knowledge. And this has a knock-on impact in lots of other areas of maths. And the CAR specifically references math skills such as reasoning and problem solving. I'm going to share a little bit later how the Curriculum Assessment Review intends to create more space. So what its solution is to that kind of overcrowding problem, and how that then gives space to teach foundational knowledge in a better way than we are currently doing. But let's get back to the math side of things specifically. So what is foundational knowledge? So I always like to think of maths as like a wall, bricks in a wall, or foundations of a house. Maths is a hierarchical subject. So you learn a skill, it then supports the development of the next skill along. And you can think of it as primary maths is like the first step on a journey towards further study and use of maths in everyday life. Like I said, maths is a hierarchical subject. So if we look at the very top of that pyramid, more advanced study requires really strong foundations in the fundamentals of the subject. You can't just jump to multivariate calculus, which is an example of the type of maths that you might get at university. But in order for our pupils to one day have the opportunity to choose to study maths in that way, we must ensure strong foundations within primary maths. And that begins with fundamentals like counting within 10, right at the start of that maths journey, the concepts of cardinality, the value of digits in our number system, for example. And after this, our pupils learn increasingly more complex and increasingly more abstract maths. In Key Stage 2, they learn about equivalent fractions, for example. And in secondary school, there's significant focus on algebra, including things like quadratic equations. And then they might move on to things such as trigonomic functions if they choose A level. And actually, we know that A level maths has been the most popular A level subject for a number of years. 40% of all A level students choose it. But whatever group of primary children you work with, bear in mind that nearly half of them will need to have foundations strong enough to access the upper levels of this pyramid. So this is where we do the fun interactive activity. Um, we're going to actually look at some examples of knowledge that are in the primary curriculum and actually in some in the secondary curriculum as well. And we're going to think about how we differentiate foundational knowledge from other mathematical knowledge. So what I'm going to do is I'm going to show a statement on the screen, and you basically have to decide, is this foundational knowledge for the year group for which it applies? So there'll be a little label at the top that says which year group it applies to, or is it not foundational knowledge for that year group? And Kate is going to flash up the poll with that question, and you literally have to answer the question. So this is the first one. We can do this as a little bit of practice. So in year three, knowing that there are 60 seconds in a minute, is that foundational knowledge for year three, or is it not foundational knowledge for year three? So I'll give you like 5 seconds. Don't think about it too hard. Fantastic. We've got a few people answering. So I don't know if you can see the results coming in real time, but if not, Kate, please share the results. So looks at 86% say it is foundational knowledge, and you would be correct. So ideally, they'd know this in year two, but this is definitely foundational knowledge. If you are a person living in the world from year three onwards, you need to know that there are 60 seconds in a minute. So that's a good example of foundational knowledge and when you need to know it. Great. So the next question, it's a good start, guys. So knowing that, let's think about a year six pupil, knowing that the formula for the area of a circle is pi r squared. Is that foundational knowledge? Is it not foundational knowledge? Kate, can you share the second poll question, please?
I am trying my best. Okay.
Great, I can see it. Is that foundational knowledge for year six? Wow, this is like super quick. People are saying not foundational knowledge straight away. And it starts easy. I was going to say it starts easy. That is correct. They don't even learn this in year six. So even knowing what a radius or circumference is in year six is not foundational knowledge. There are absolutely more important things to know in the curriculum in year six. So that is not foundational knowledge. Well done, everybody. How about, though, in year 11? Is knowing that the formula of the area of a circle foundational knowledge in year 11? The poll should come up, and let's see what you think. You might be able to see where this is going, but there are some trickier questions coming up. Brilliant. So everybody, apart from one, said that would be foundational knowledge. And you would be correct. So in year 11, especially when you're doing GCSE maths, there is a huge amount of circle-based maths, and having automaticity, so actually being really, really familiar with that formula, allows pupils to focus on that area of the curriculum and and do stuff with that knowledge. So just knowing it automatically is super important when you're year 11, but is not important when you are in year six. Okay, brilliant. Next question. You're in year five, knowing the position of the X and Y axes. Is that foundational knowledge? Not foundational knowledge. This is an interesting one because you might think shape and space. It's not number. It's not that really core important area of the curriculum. Is it foundational knowledge? Is it not? Little bit of a split opinion, 80% to 20%. And this isn't definitive, by the way. This is just my opinion, and you can agree or disagree. So actually, I think this is foundational because actually in year five, there is a significant amount of knowledge in both stats and in coordinate geometry that become really hard if you don't know what X and Y means and what that looks like, if you don't completely kind of intuitively understand that. So there's a link here between like the type of maths that this foundational knowledge kind of underpins and unlocks, and whether or not therefore it's foundational. How about year two, knowing that 2/4 is equivalent to a half in year two? Bit more of a split. I can see, not sure if this allows you to change your mind halfway through, but yeah, it's almost a 50-50 split, actually. Really interesting. So half of you think that that is foundational knowledge, half of you think that it is not. Um, well, I don't think it is in year two, and I'll say why. So knowing that fractions can be equivalent is really, really important. Okay, it's a super important thing that kids need to know. Knowing this specific relationship is definitely foundational knowledge, but it's not foundational knowledge yet. And if pupils haven't learnt this relationship perfectly by the end of year two, but have secured the other core knowledge in that year group, such as addition and subtraction facts within 20, which is absolutely vital, then that's okay. So if you're a year two teacher and your kids can't do this, then you can breathe a little bit of a sigh of relief. Couple more. So year one, knowing that 78 is made up of 7 tens and 8 ones. And I appreciate some of you may not be working in year one or year two, and that's okay. Um, most people saying that that's not foundational knowledge, but a little bit of a split. Again, not really, and that's because tens and ones, that element of place value is not covered in year one. But, and you can probably see where this is going, what about in year two? Is that foundational knowledge or not foundational knowledge? Yeah, everybody's saying yes, absolutely. This is fundamental knowledge for year two pupils. And there is absolutely no point moving on to the year three place value knowledge of hundreds if pupils aren't really super secure with their knowledge of place value with tens and ones. Okay, this is the last little set. So year four, this is going back to shape and space. Knowing the numbers of lines of symmetry each type of quadrilateral has. Brilliant. Yeah. Again, by the way, there's no document necessarily that says whether these things are, but I think everybody agrees that year four, knowing how to find the numbers of lines of symmetry in each type of quadrilateral is important, but it's not foundational knowledge. Knowing the exact number of lines of symmetry for a kite, a square, a parallelogram, a rhombus, a rectangle, or inverted kite, a trapezium is in year four. It's just unfeasible and actually unnecessary when it's not a set of facts that is frequently required to work mathematically across topics. So again, it's that idea of like foundational knowledge is the stuff that you absolutely need to unlock lots of other different types of knowledge. What about in year six, though? Same question, knowing the numbers of lines of symmetry each type of quadrilateral has. And I'm not saying like you need this to be able to pass your SATs, but thinking about it like as the most important bits of knowledge you need. I would argue still not foundational. What about in year 11? Remember, think about that kind of phrase, the most important knowledge that you need to have at any given time. I would actually argue that in year 11, this is still not foundational. And it kind of will never be foundational. It doesn't mean it's not important, but it won't be foundational knowledge. And that's because you can live a productive mathematical life without knowing this. Um, Last questions. What about knowing the multiplication and division facts to 12 multiplied by 12 in year three? Yeah, not foundational. Knowing all the ones up to 12 by 12 is not foundational, but knowing some of those multiplication facts, such as twos, threes, fives, is foundational learning. But what about by year five? Knowing the multiplication division facts to 12 by 12 by year five. And we're going to come to multiplication division facts later. Yeah, everybody straight away. Absolutely. All of our pupils should know all the multiplication and division facts in order to work mathematically across a range of topics. They come into fractions, area, perimeter, and of course, so many multiplication and division calculations. And this is a really good example, and we'll come back to it later, of a really core bit of foundational knowledge that you absolutely need your pupils in year five to have secure. Okay, brilliant. That's the end of the poll. You'll be pleased to know. Well done, Kate, for facilitating that. That worked really, really well. Um, okay, so the key points here. And by the way, I think it's really great to actually share some of these examples. So in your schools, feel free to share some of the examples, make up some of your own examples, but actually open up a conversation about foundational knowledge and get teachers to really think about discerning which knowledge is foundational and which isn't, because this is absolutely the starting point for teaching foundational knowledge really, really well, knowing what to focus on and which bits are like totally non-negotiable and which are a little bit more contingent. But some really key points to remember. Some knowledge is absolutely always foundational. And actually, because we're primary practitioners, a lot of that early maths is just all foundational. Um, and it's really super important. We have to prioritize counting, one-to-one correspondence, ordinality. And that's why early years maths and particularly Key Stage 1 maths is so, so important. So really having a good quality offer in early years of Key Stage 1 is absolutely vital. And again, Ofsted, all the inspection reports that we've seen so far, they go into early years and Key Stage 1 and they go over it with a fine-tooth comb, making sure that these kinds of things are being served really, really well. So if you're not sure if that's the case in your school, have a bit of a reflect and a think about what you need to do to make it so. So some knowledge is always foundational. Some knowledge becomes foundational. So we saw that with some of the examples in the quiz. Um, Beyond the points where they become foundational, further mathematical learning requires it. So multiplication, division, facts, and key like fractions, decimal percentage equivalents, they rely on some foundational knowledge, some multiplication, division knowledge. But some knowledge is never foundational. It doesn't mean it's not useful, doesn't mean it's not important, but it is not required to access significant areas of maths. And I think it's really important that teachers kind of know which bits are which bits do we absolutely focus on, and which bits can we kind of be less worried about if pupils aren't getting it. Um, Great. I'm going to pause there. I've just seen a hand up. Kate, are there any questions in the chat, or is there anyone that wants to unmute and ask a question?
There's no questions in the chat at the moment. I wonder if the raised hand it's gone down again, so I wonder if maybe it was a mistake.
Oh, okay. Feel free to raise your hand if you have a question, and I will stop and we can have a discussion. But hopefully this is getting you thinking. So, um, I just wanted to make this point. I want to share this example because I see this thinking a lot in the schools I work in. So, namely, teachers see pupils who get formal written method questions like this wrong. And typically, the solution, which sounds intuitive, is to do more of this type of question. You think they can't do it, let's do some practice and let's do more of it. However, in this case, it's not often the procedural elements that make this tricky. So doing more of it, doing more of the procedure doesn't necessarily make you better at it. And actually, the procedure can be taught pretty easily. You can teach kids to start from the right, go to the left, etc. It's actually the underlying maths, specifically number fact knowledge, that a pupil might not be confident in. And this is the thing that should be addressed first. So, for example, knowing that 7 plus 4 is 11, that might be the thing that pupils are not able to do quickly, and that's why they're getting these questions wrong. So, when considering teaching something like this, ask yourself, what foundational knowledge is needed, and also actually what makes this hard. Like this calculation, doing the procedure is not the hard bit, but actually for some pupils, knowing those number relationships, those number bonds, is potentially what they can't do, and that's the thing that you need to focus on. Um, so a little bit of reflection time, and again, feel free to put things in the chat. Think about your school. Do you know in your year group, do you know what the foundational knowledge is? If you don't know what it is, do you know where to go to find out? Are these the type of conversations that you're having in your schools? So just have a little reflect, 10 seconds, 20 seconds. Um, and please put any reflections in the chat if you feel comfortable to do so. And Kate, if you see any chatter, please share, but no worries if not. Great. So I asked the question, do you know where to find out what this foundational knowledge is? And I'm sure you all know this set of documents, the Ready to Progress criteria. This is a good place to start. So these criteria provide really clear guidance for what pupils should know as a priority and where to start. For each year group, you need to be sure that your pupils can do all of the things in these criteria, because this is like the prerequisite set of knowledge needed for later maths. And this should form the absolute spine of your curriculum offer. Ben, I can see your hands up. Go for it. Feel free to chip in or type in the chat if you're not able to. I'm not sure what the settings are. Um, so ready to progress criteria. I'll just share, you may not be using Maths Mastery Primary, but for our program, we have these documents which are covered for every unit. These are our kind of roadmaps of what the knowledge that is being taught in that unit looks like. And what we do is we try and really surface that foundational knowledge. And any good curriculum offer will surface the foundational knowledge so that it's really clear what pupils absolutely need to be able to do as a non-negotiable. Again, this is an example from our program from year five, and you can see that there's a lot for pupils to do in that unit. It's a 3-week unit. And it would be really easy for some of that foundational knowledge to be lost. So what we do in the ARC schools is we use these roadmaps, and in the planning and co-planning sessions that teachers do with each other, they actually find the foundational knowledge, they circle it, and they share what that is, and they have debates about whether that actually is the foundational knowledge or not, so that when they actually teach the lessons, they know the things that are absolutely non-negotiable for their pupils to know by the end of the learning, and what's a nice to have. I thought I'd just share some examples that I'm sure will be really, really familiar. How do you know when pupils don't have the foundational knowledge that they need? So obviously schools do a huge amount of kind of formal assessment, but also informal formative practices. In Maths Mastery Primary, we do pre-unit quizzes, and that's designed to identify whether pupils have got that foundational knowledge. But you might not necessarily be sure. I think if you see these things in your schools, this is a kind of proxy for, okay, there are some foundational things that are not in place. So if you see pupils using their fingers to make basic addition or subtraction calculations, particularly higher up in like 3, 4 and above, and they don't just know their number bonds, that's a sign that you need to go back and address that gap in number bond knowledge, because it is absolutely, and I'm sure you can see that it's stopping them accessing the more complex maths and it's slowing them down. And similarly, if pupils are using lots of written scaffolds, so times tables, grids that we're referring to, which are fine, but you want pupils to move away from those scaffolds and be automatic in that knowledge as soon as possible so that they can free their brains, their short-term memory for more complex, harder things later on. And yeah, and a simple one again, if you're doing a book look, if you're a middle leader, a maths lead, and you're doing book looks, and there's just consistently not a great amount of completed content from certain pupils, well, there's an obvious alarm bell there. They might not have some basic knowledge that's allowing them to get to completing a decent amount of work. And these are the conversations that you can have with your colleagues in your school as well. Are you seeing these things? What does that tell us about the foundational knowledge that our pupils have? So these are the places in Maths Mastery Primary where foundational knowledge learning happens. And I would say ask as a school, if you're a leader especially, is there sufficient time to teach foundational knowledge? So we do maths meetings, which are like a separate specific um, kind of point in time where you can practice multiplication division facts, number bonds, doubles, things like that. Super quick. It's a bit like a sort of mini phonics session, but for maths that happens outside of the core learning. The perfect time to develop some of that foundational knowledge. So, as a leader, do you scaffold each year group through the timetable to have enough time to do those things? And actually, when it is there, is it signposted really clearly? And that teachers know that, okay, we're doing maths meetings, and maths meetings are for making sure your pupils have that foundational knowledge. And if those aren't the case in your school, you need to think, okay, what do we need to do to fix that? So again, a little bit of reflection time, and these slides will be shared as well. So you can maybe take some of these prompt questions away to your team and share. Would be a nice like staff meeting activity. So do your teachers know what the foundational knowledge is for their year group? The kind of non-negotiable stuff kids have to be able to do before they leave that year group. Do they frequently look for that foundational knowledge when they're doing their planning? If they know that there are gaps, um, how do they fill those gaps? What are the processes for assessing and then identifying and then acting on that formative knowledge? Yeah, and just this wider point of like, this is something that we need to be really conscious of, not just because of Ofsted, but um, Ofsted will look for these things if they come in and do an inspection. And I guess further reflection, what will you do next to make sure that you have sufficient curriculum time to support foundational knowledge? Um, we've mentioned number facts a few times. How do you explicitly support the development of pupil knowledge in their number facts and multiplication division facts? Um, this is a little bit of a slightly more provocative challenge in your school. Obviously, phonics is a huge focus, rightly so, but is the same rigor and expectation for pupils knowing their sounds by the end of year two given to, for example, knowing number bonds to 20? Do you have the same kind of expectation that every pupil has got to have that by the time they leave year two? Um, Arguably, most schools don't quite see it in that category, but really, it's just as important because it's as foundational to maths, your number bonds, as knowing your sounds is to reading and literacy. This is just a little bit of a sort of slight detour back into the curriculum assessment review. And I just wanted to mention this idea of resequencing. So before we get into multiplication division, which I do want to share right at the end of this session, I want to zoom briefly back into the curriculum assessment review. As we've seen, it acknowledges that foundational knowledge is an absolute priority. But actually, what does it say about what it's going to do at a curriculum level to make sure that foundational knowledge is taught better? So again, this is text from Carr, and I'll give you a second to read it. So in a nutshell, too much is introduced too quickly. People often talk about the curriculum conveyor belt. That's kind of what that means. And that packing of the curriculum inhibits the focus on foundational knowledge. Teachers have to move on to other stuff before they've really secured that foundational knowledge. So the CARS solution is, right, we're going to resequence the curriculum. And I just wanted to give one example to share what that looks like. We are going to see a draft version of the new curriculum in about a month or two. So we'll actually see what for sure is going to be moved and where it's going to be moved to. So let's take as an example fractions. So resequencing is less about removing or replacing content. So a lot of the chatter with the new curriculum was about what's going to be gone and what is it going to be replaced with, or where's something going to be moved to. It's actually thinking about reorganizing content so it can be taught more effectively and so that pupils learn and retain knowledge in a better way. So let's take, for example, complex fractions calculations. And what I mean by that is things like in upper key stage 2, typically you might do like 2 in a sixth plus 2/5. This is actually a question from the 2025 arithmetic paper from SATs. But what the resequencing is proposing is actually that will get removed. I'm not saying it will definitely get removed, but this is an example of what could happen. Let's remove complex fractions calculations from key stage two. Um, let's actually move introduction of fractions, which is currently in key stage one, into key stage two. So that space that we've created by removing key stage complex fractions calculation from key stage two, we're moving up the introduction of fractions, and that therefore creates space in key stage one for more time and effort to really nail foundational number skills, things like number bonds. And that's made possible because, for example, complex fraction calculations, they're basically taught twice currently. You get them taught in Key Stage 2, but they're also retaught from first principles in Key Stage 3. And that's just not efficient. These are some examples of topics in the current curriculum that could be moved. Again, this is a great example of a webinar that will go out of date probably in about 2 months, but this is my best guess as to the things that might move. And there are some things that kind of exist that are here for historical reasons, like we talk about kilometers to miles conversions. Actually, the 12 times table exists because we used to need to be able to use things in multiples of 12 a lot more when we had the imperial measurement system. Do we necessarily need that in the way that we once did? Not sure. But actually, taking some things out, moving other things around creates space. And the key message really is that we are creating space for that foundational knowledge. I just wanted to briefly mention these phrases: additive reasoning, multiplicative reasoning. This is basically how the card describes the focus areas for each key stage, and how grouping similar knowledge types into key stages supports a kind of a better cohesion and supports making conceptual development visible to teachers and learners. But there will be a greater emphasis on the foundational knowledge in those key stages. Okay, so I wanted to go to one example of foundational knowledge, which I've mentioned a few times. I wanted to highlight this because multiplication and division facts are almost the most foundational of foundational knowledge. And also, as I said, we've recently created some new resources to teach multiplication and division facts, which is called Fact Foundations for Multiplication and Division. So I'll talk a little bit about that, and I'll share some resources as well. And at the end, Kate will let you know how you can find out a little bit more about Maths Mastery Primary in general, but specifically this new resource. Okay, so why are these facts important to teach and to prioritize? So we know that multiplication division underpins so many later, more complex areas of maths. So fractions, use of formal methods, worded problems, ratio and proportion, area and perimeter. And note that I'm referring to multiplication and division facts, not just times tables. Yes, we know that pupils need to know the times tables for the multiplication tables check in year 4, but really to be prepared properly for success in maths, it's important pupils know all their multiplication and division facts. For example, 4 multiplied by 3 equals 12 is in the 3 times table, but pupils should equally be confident knowing all of the associated facts related to that core fact of 4 multiplied by 3. So when pupils use our program fact foundations, they're introduced to that focus fact, 4 multiplied by 3, but they get really, really good and fluent and automatic in knowing all of the associated facts in that fact family. So you want pupils to go 4, 3, 12, those numbers, they're like best friends. Those facts are things that I intuitively relate to each other. And that helps me just to develop that automaticity and those connections and links. We know that pupils need to understand what's going on when we multiply and divide. This is covered in our core daily teaching offer, but we also want to hammer that home in every session of Fact Foundations. So that use of arrays, which show in a really careful, considered representation what is actually going on when we're multiplying. We're showing groups of a number and why that relates to multiplication, and that's a multiplicative relationship as opposed to an additive relationship. Um, but ultimately, pupils need to know these facts automatically. So they've got to have that understanding of what multiplication division is and that conceptual understanding. And actually, automaticity helps develop that. But really, to be useful in their mathematical lives, they need to know those facts automatically without having to use strategies to calculate those facts, because that just slows down. So how do you develop this automaticity? So the best advice, and I think lots of program providers would be saying the same things, is to actually treat teaching multiplication division facts like teaching phonics. So you've got to start by being really systematic about identifying the facts that pupils know. Just like in phonics, you have the sounds and you teach them systematically. It's not random, the order in which you teach sounds. You teach them in a very, very specific order. It's the same with multiplication and division facts. Teach them in an intentional way so that you can make links and make them meaningful. And just like in phonics, which is super rigorous about seeing what those facts are, and if kids don't have them, plugging those gaps, do the same with multiplication and division facts. So when you're teaching your multiplication and division facts systematically, lots of practice, lots of formative assessment, make sure that you can see which pupils can do them, which pupils need extra practice, and those pupils get that extra practice. This is the order that we teach the different times tables for fact foundations. And you can probably see, just looking at this grid, why certain times tables have been taught in relation to others. For example, doubles, and we start with doubles because there's a really lovely bridge between the additive curriculum that pupils get in Key Stage 1 and knowing that two numbers that are the same added together has a doubling relationship. But that really closely then bridges into the 2 times table. Similarly, 10 times table and 5 times table, there's an obvious link there. And then things like 4s and 8s and 3s and 6. And it's really important that we expose pupils to those links and explicitly refer to those connections so that pupils can see that and see the patterns in the multiplication relationships. Our program, and I'm saying this as an example, but really to teach multiplication division facts well, teach it like phonics, have a plan, have a plan that goes across those 2 years, do it systematically. We do every times table unit is 5 weeks, and there are 2 sessions per week. And that's how it all gets fitted into the 2 years of years 3 and 4. Going to really quickly look at the learning in each session. And again, this is an example, but the principles here apply to any learning of multiplication division facts. So we have 3 types of session. So session 1 is basically introducing the times table. We always do a fact flashback, and that's basically practicing previously learnt facts. Just like phonics, you practice the sounds you've learned. With this, you're practicing the facts that you've already learned. You've got to constantly be practicing them so that they become automatic. They go into that long-term memory. And then in session 1, there is an introduction of the times table. That's the new learning. And the pupils will learn a chant. And I'll talk a little bit about chants in a minute. As I said before, all of the times tables, the core representation is the array. So it's introducing the new times tables so pupils can see what that times table looks like and link it to those core facts. Session 2 is all about making connections. So according to the order of the times tables that have been introduced, pupils will then look at connections between times tables. This is not overblown. It's not done as a sort of separate lesson. It's just going, oh, look, we know this fact and we've seen this before. This new fact that we're going to learn, there's an interesting relationship and we're just calling that out and exposing that. So the example here is looking at how a fact from the 2 times table can relate to a fact in the 4 times table. For example, you halve one of the factors in the equation, you need to double the other factor to give you the same amount. It's an interesting structure to expose. So all of the times tables have at least one lesson where there's an interesting connection that's made. But the vast majority of sessions, it's all about practice. It's all about recall and rapid recall of those facts. And that's what sessions 3 to 10 are. They all include chanting. So actually hearing the times table in a certain order. I'll show you an example of the first chant. and it's exactly probably as you remember your times tables being taught, where you've got the pattern 2 4s are 8. The second chant is a little bit more unusual. That's basically just the numbers, and this is designed to anchor those three numbers which make up each fact family, because you want that connection to be really intuitive. For example, when pupils see 4, automatically go, oh, there's a 6 relationship there because 4 6s are 24, 4 6 24. And this is really important. And you can imagine, like, when pupils are trying to answer missing number calculations, being able to sort of intuitively see what number relationships go together is really, really helpful in maths. Um, yeah, so the new learning in this session is where pupils are exposed in a systematic way to the new focus fact, exactly like in phonics, where you're doing your new sounds. It follows the same pattern, the same script, and at the end of each session, there's a booklet, and pupils do a load of practice. So there's tons and tons of questions across the whole program. Pupils are getting exposed to literally hundreds of the facts, so that they are going into that long-term memory. Okay. I mentioned associating three numbers together in that fact family. This is basically how we show that in that fact triangle. Um, we also really intentionally choose the facts. So it's not just random stuff that they've done before. We actually really have thought about which facts are more useful to know. For example, 6 multiplied by 4 is 24 is much more useful than 6 multiplied by 1 is 6, because you're going to use 6 multiplied by 4 is 24 so many more times in your mathematical life. So actually practicing that fact way more than 6 multiplied by 1 has been built into the slide so that they're getting more examples of that question type coming up. And I mentioned that there are two ways in terms of the facts being practiced. First, the more familiar, something multiplied by something equals something, like 5 multiplied by 4 equals 20, but also when the answer is not the product, it's one of the factors. So multiplied by 4 is 20. So actually, even from the very start of these resources, you're getting practice in those missing number questions, which are the things that people typically find more tricky. And the same with the corresponding division facts. Right. So we've got about 10 minutes left. I really want to give you guys an opportunity to ask questions. Before we get there, hopefully you've been able to take away some things from this webinar. These are the things that I think are probably the most useful. This idea that foundational knowledge, like what it actually is. And again, for me, this simple definition is super helpful. It's the most important knowledge pupils need to know. Okay. It's simple, but also you need to know what that is. And leaders in the room, you need to be thinking, how am I supporting my teachers to know what that knowledge is? Okay, they need to have good subject knowledge. If you're in year 2, you need to know what the foundational knowledge is for year 2. If you're in year 6, you need to know what it's like for year 6. And you need to kind of have the attitude of like, I'm not going to let these kids leave my year group without knowing this stuff. And if there's a risk of that, I've got to do something about it. And I think if everybody had that approach, which is kind of what we do for phonics, you wouldn't see those gaps appearing later on in a pupil's mathematical life. Yeah, so absolute leaders have got to give good amounts of time to their staff to develop that subject knowledge. Like I said, the curriculum assessment review is making this a priority, and it's already a priority in Ofsted. So there's a sort of survival instinct rationale to knowing what your foundational knowledge is. We've got a colleague in ARC who is an HMI, and he basically is like, if I go into a school and the school tells me they know what the foundational knowledge is for the year group and they know why it's the foundational knowledge, he's like, tick, 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 great, great, great. It's absolutely what they're looking for. I would recommend looking at some key areas like number facts, looking at early years, looking at one-to-one correspondence, counting. How systematically are you making sure that pupils have those skills? How do you know that they've got those skills? And if you've got pupils with gaps, what are you doing about it? Further up the school, we did a little look at multiplication division facts. Again, if pupils are getting to the end of year 4 or 5 and they don't know their multiplication division facts or they're making mistakes, go back, teach them again. Don't let them get any further without knowing those things, because they will thank you for it, not just in their school life, but in their life. Knowing your times tables, super, super helpful. Okay, I'm going to hand over to Kate in a second because she'll give you some tips on what to do next if you want to learn more about our resources specifically. Um, I just want to say a big thank you. I know what it's like on a Wednesday afternoon, midweek in the summer term. I know lots of you have probably got SATs coming up as well. Thank you for your time. If anyone's got any questions, feel free to unmute and ask them now. Feel free to put them in the chat. We'll monitor that. I'm on LinkedIn. I'm also available via, obviously, Mathematics Mastery Primary. Um, I'll hand over to Kate just to kind of finish things up. And yeah, if there are any questions, please do ask them now.
No questions so far, Will. Oh, got a thank you, not a question. But thank you to everyone who attended. I hope you found that really interesting. I know I definitely did.